Chapter 3: Stepwise Thinking. Topics covered: step-by-step planning of any activity. Identify main and detailed sequence of steps of an activity. Every activity has a sequence of steps that need to be followed. First, list the main steps of the activity. Then, for each main step, list the detailed steps. Listing the steps helps in carrying out the activity easily. Now, if you see in real life, we follow certain steps to perform any task. For example, if we need to make a bread sandwich, we need to follow certain steps. Steps to make a bread sandwich. Arrange all the ingredients in the required quantity. 2 bread slices, butter, 1 onion, 1 tomato, lettuce, cucumber slices. 1. Spread some butter on your bread. 2. Layer the lettuce on top of the bottom slice, add onion rings and tomato slices. Also add cucumber slices. 3. Sprinkle salt and black pepper as per your taste. 4. For every person who is going to have sandwich, take 2 bread slices and prepare as shown above. 5. Serve the sandwich and enjoy it. This is how stepwise thinking is done. Steps to pack your school bag for the next day. 1. Open the bag. 2. Take out your school diary. 3. See the timetable. 4. Go to the bookshelf. 5. Take out the required books and notebooks. 6. Keep them in a bag. 7. Close the bag. Steps to prepare banana milkshake of taking the help of your mother. 1. Pick 1 banana from the fruit basket. 2. Peel it off and cut it into small pieces. 3. Put these pieces in the blender. 4. Add 1 glass of milk and 1 teaspoon of sugar in the blender. Cyber tidbits. The IPPO cycle of computer works on stepwise thinking. First it takes input, then processes it and finally gives the output. Stepwise thinking refers to converting complicated tasks into simple steps by predicting the possible solutions to achieve a desired outcome. We have already studied that all the thinking in a computer takes place through input, process, output. 1. We use mouse, keyboard and touchscreen to give input to the computer. A computer works on a set of instructions called programs. A computer completely depends on our instructions for its working. 2. Processing is the main step in thinking work. The computer performs calculations on the data provided as input according to the instructions, or program, given by the user. 3. Finally, the result is provided to the user. This final result is called the output. Printer, monitor and speakers are known as output devices. Microprocessor, scanner, camera, mouse, keyboard, printer, speakers, monitor, printer. Input: printer receives a document from a computer. Process: the printer stores the document in its memory. Output: a document is printed out onto paper. Microwave. Input: user presses buttons to select the power level and time. Process: the microwave switches to the allocated mode and heats up the contents for the duration selected. Output: the microwave beeps and the user removes heated food. Algorithm and flowcharts. The steps written in an order to solve a particular problem is called an algorithm. Step-by-step division of work helps in completing it on time. The steps written in algorithms can be represented diagrammatically with the help of a flowchart. Note that algorithms and flowcharts are not required for a computer but are used by a programmer to understand the program easily. A flowchart is a diagram that represents a set of instructions. Flowcharts normally use standard symbols to represent the different types of instructions. These symbols are used to construct the flowchart and show the step-by-step solution to the problem. The commonly used symbols for drawing a flowchart are given below. Terminal box. It is the starting/ending point in a flowchart. While creating a flowchart, we write start or stop inside this box. Input/output box. To make any type of input in the computer or display an output, this box is used. Process box. All the steps involving processing work are written inside it. We can use as many boxes as we want to write the number of processing steps. Flow lines. These are the arrows in a flowchart that connects two boxes that determine the sequence of the program. These lines generally flow from top to bottom direction. Decision to ask a question that can be answered in a binary format, yes/no, true/false. Connector allows the flowchart to be drawn without intersecting lines or without a reverse flow. Now here is a simple flowchart for calculating the sum of three numbers. Start. Accept the values of A, B, and C. Calculate sum equals A plus B plus C. Print the value of sum. Stop. Algorithm for the above flowchart is given as follows. 1. Start. 2. Accept the values of A, B and C. 3. Calculate sum equals A plus B plus C. 4. Print the value of sum. 5. Stop.